that is if your partial derivative exists, it does not imply function is differentiable. That is existence of partial derivative does not imply f is differentiable. Then that is okay, that it has all the partial derivative, correct? Because if it is differentiable, that means it has all directional derivative in all direction. So in standard vectors, if you take, then you will get partial derivative, but it is the converse is not true. So let us see a function, say f of x y. This question is there in your assignment in, I think, one group, either group A or B, even number or odd number. You'll see. Okay. So can you easily check this function is continuous? It can be easily see that this function is continuous around 0 0, you can say. Okay. So let us see what is fx at 0 0. First of all, you have to check that partial derivative exist. Existence of partial derivative does not imply f is differential. That means I want to prove each of the partial derivative exists, but still the function is not differential. That is my claim. Correct? So let us see. What is dou f by dou x? That is limit h tending to 0. That is f of h comma 0 minus f of 0 0, same thing, upon h. So what is that? If you put it here, it will be 0, na? See, 0 into h, so it will be 0. Same dou f by dou y. At 0 0, it will be limit k tending to 0. It will be f of 0 comma k minus f of 0 0 and divide by k. So again, if you put it in this function, you'll be getting 0. That's it. So this is also 0. So each of the partial derivative, that is 0, and both exist. So what can I say? So fx and fy both exist at 0 0. What else I have to check now? Whether it is differentiable or not. Okay. Suppose it is differentiable. Let us take. Suppose f is differentiable. Then what will I have? Then that is df of 0, it will be t. And how do we calculate this t? That is delta f into h. That is this df of 0 0 at h comma k, it will be delta f of 0 0 into h comma, which I just now told you, and that will be your t of h comma k. So this is your t of h comma k, the whole left hand side. This is what you already know, these fx and fy, they are 0. So 0 0 multiplied by h into k, so it is 0. So this is done. Now you have to check whether that limit exists or not for differentiability. That is limit h comma k tend to 0 0, and this is f of h comma k minus f of 0 0 minus t of h comma k. You just remember this thing, huh? You just have to find t of hk, and then you have to do this. This is the technique you should use always. And divide by root of h square plus k square. Let us put it in the function. That is limit h comma k tend to 0 0. What is f of hk? It will be root of mod hk minus f of 0, and everything is 0, and this is divided by root of h square plus k square. Now see, now we will see that there is some issue. Okay, let us take this limit along some curve. Let us say along k equal to mh, because if this limit exists, then it exists in all the direction. If you take all the curve, if you take any curve, so I'm taking let us take along this k equal to mh, I'm taking. That means now my key will be in terms of h, and everything will be in terms of h. So what I will be having, say limit h comma k tending to 0 0. This will be your h square, so your mod h will be outside root m, upon in the denominator also it will be mod h root of 1 plus m square. So you see h will get cancelled. I will be having what? root m upon 1 plus m square. So what can I say? Correct, it depends on your m. That is, if I change different value of m, I'm having different values of this limit. So that means hence limit does not exist. This violates the condition of uniqueness of limit. I hope you agree with that. Correct. So what is the issue here? That is, for different value of m, I'm getting different value of this limit. Hence the limit does not exist. So you can say which is different for different values of m. So what can I say now? That means hence limit does not exist. Hence limit does not exist. And what do you will say? That is f is not differentiable. F is not differentiable. So did I prove that? Correct. So what did I prove? See, you can should write differentiable implies partial derivative exist, not converse. That is, partial derivative exist does not imply differentiability. This is what we just now proved. Correct? Good. Okay. Now let us do some examples. Suppose you are having some functions and you want to find the partial derivatives, or you want to find total derivative. Let us see. Find total derivative. Total derivative, say f of x y z, that is equal to, say, x raised to y raised to z. Suppose this is my function and I have to find total derivative at 1 2 1. How will you do? Now you have the trick that how to calculate total derivative, correct? Now they are saying find the total derivative. They are not telling you to check whether total derivative exists. So you know that they are saying find total derivative. That means total derivative definitely exists. And what will be our total derivative? That is, you already know, that is del f at जो भी point है 1 to 1 into your h1 h2 h3 or whatever you say, or any vector, 3 vector चाहिए तो say u1 u2 u3. So you just have to calculate this. So this will be fx into u1 plus fy into u2 plus fz into u3. That's it. This is your answer. You just have to calculate fx, fy, fz. See, remember one thing, in the question it is asking find the total derivative. Correct? So that means let us quickly see what is fx. Fx क्या आएगा? You have to differentiate with respect to x. So it will be x raised to something. So that something is constant for me for x. This is variable for y z, but this is constant for x. So it will be what? Y raised to z, x raised to what? Y raised to z minus 1. I hope it is clear, and put at that point fx at 1 2 1, put the point and get same fy. For y you are having, this is x raised to y, so this is of the form e raised to x, that is constant raised to y. So what you will do, this is x raised to y raised to z into log of y raised to z. Correct? E raised to x log a, if you remember. This is constant e, this is your x, at the place of x there is y raised to z. So actually you have to differentiate once again, that is by chain rule, that is e raised to x log, sorry, this should be log x, no? I'm sorry, because x is constant. So this will be e raised to x log x, and that is multiplied by derivative of y raised to z. So that is z into y raised to z minus 1. I hope this is clear to you. And put it the point, that is 1 to 1. And what will be third? Fz. So for fz, this is again x raised to y, xy raised to z. Correct? So again this is e raised to x form. So how do you do? See, one more thing, if you don't like this method of doing partial derivative, you can use your definition, that is fz का definition क्या आएगा, limit say h tending to 0, it will be f of whatever point is 1 comma 2 comma, at the z coordinate you should write 1 plus h and minus f of 1 comma 2 comma 1 डिवाइड बाय एच. वेन एवर यू हैव सम डाउट कि हाँ ऐसा करेंगे तो कुछ इशू आएगा, तो ये कर लो, जस्ट इसमें सब्सटीट्यूट करना रहेगा, दैट्स इट. देयर इज नॉट एट ऑल प्रॉब्लम हियर, यू विल गेट दैट. So it is your choice whether you want to follow this or you want to do that. Okay. Yeah. Actually, I have tried to cover all the types, different types of problems. You just see. Say, suppose you want to find this using chain rule. Oh, this is quite. Find dz by dt using chain rule. You are having z equal to f of xy, where it is say 4x square plus 3y into log of 3x plus 4y, say 3x plus 4y. So this is what your function z is, where x is in terms of t, that is sine 2t, y is in terms of cos 2t, and say at t equal to pi by 4. Okay, so you want to calculate dz by dt. Look at first thing, z is in terms of x and y, so that means what, you have to find dou z by dou x, and you have to calculate dou x by dou t, as simple as that. And here dou z by dou y and dou y by dou t, that's it. Just you quickly calculate that and put the values here, you'll get that. You'll in last you have to put t equal to pi by 4, that's it. Correct. Yeah. And one more type of question, I think ये भी हम लोग ने किया है, that is determine the direction in which f of xyz f of xyz, that is equal to say e raised to xyz multiply by xy plus yz plus zx. This is your function having first increases fastest, the fastest, second decreases the fastest, you have to find the direction, determine the direction, and third one is does not change at 110. Okay, also find maximum rate of change of f at that point. So this is the question, determine the direction in which the function increases the fastest, decreases the fastest, does not change in that. So whenever you see, first thing you have to calculate delta f. So you are having the function f of xyz, that is equal to e raised to xyz multiply by xy plus yz plus zx. So quickly calculate fx, fy, fz. The next thing you have to calculate fx at the point 110, fy at the point 110, fz at the point 110. Okay, so this will give you your delta f at 110, that is your fx at 110 comma fy at 110 and fz 110. Correct. So let us quickly, you have to apply u into v here. So what will be this? You just calculate one and you can write similarly everything. So let us write say e raised to xyz derivative xyz as it is. So let us write xy plus yz plus zx multiply by e raised to xyz ka derivative, it will be e raised to xyz multiply by yz. Correct. And plus it will be, this guy will be as it is derivative of x with respect to us, so this will be e raised to xyz with respect to this will be y plus z. So that's it. So that's it what you are having. So similarly what will be fy, same thing at the place of जहाँ पे भी yz देखा, so it will be the same xy plus yz plus zx e raised to xyz and here it will be yz. तो यहाँ पे क्या आएगा, this was with respect to x, so this is y, so it will be xz plus same e raised to xyz. यहाँ पे with respect to x I was getting y plus z, so I'll be having here x plus z. Correct. Similarly xy plus yz plus zx, you don't have to waste time in doing, so you just similarly write here this was y xz, so here z, so it will be xy and plus e raised to xyz multiply by x plus y. Put the points 110, put the points and quickly get that सबका 110 ना, हाँ xy, so it will be 1 0, okay, it will be 1 and same fy is doing same, but here z coordinate is 0, so this will be something is 110. Here it will be xy, here it will be 1 now, but e raised to 0, so it will be 1, it will be 3 I think, just quickly check. So I'll be having 1 1 and 3. This is your del f. Okay, now let us answer the questions. Increases the fastest in which direction? You already know what is that direction, that is delta f. Decreases the fastest in which direction? That is minus delta f. So let us quickly write. Once you are done with delta f, then that's it. The direction in which f increases the fastest, you know what is the direction, that is delta f at 110, that is 113 na? And the direction in which f decreases fastest, that is the direction minus delta f at 110, so that is -1 -1 -3. So ये दोनों हो गया. And does not change कौन से डायरेक्शन में होता है, that is direction which is perpendicular to delta f. So what do you mean by perpendicular? That means dot product 0, so you just write it. The direction in which f does not change is the direction orthogonal to delta f. Correct. So let us find that direction. So if alpha, beta, gamma is any vector, so I have to calculate that perpendicular. So 113 multiplied by alpha, beta, gamma, that is equal to 0. So you just have to take some alpha, beta and gamma, and that will be the direction. Correct. So you may take example. So choose alpha, beta, gamma as this 1 put gamma as 0, so ये हो गया, so 1 and -1, so this is the direction in which it does not change. So there are infinitely many points, but I can take this. So f does not change in the direction 1 -1 0. That's it. Correct. And something they were asking about maximum value, correct? And also find the maximum rate of change. So maximum rate of change क्या होता है? That is norm of delta f. So every answer is norm. Maximum rate of change, that is equal to norm of delta f. That is norm of 113, na? So it will be that square root of 1 plus 1 plus 9. That is 11. This is your final answer. That is your maximum rate of change. Correct? Yeah, good. Okay, and any other problem? Yeah, that's it. Even I think I have covered all the things. So this completes your unit 2. From next lecture we will start with unit 3. Unit 3 is application, so there is not much theorem. We'll be doing just application there. Okay, and I'll request you to please practice this thing. If you go to the practicals, you see there are so many questions asking about continuity, partial derivative, differentiability. Follow the definition and try to see whether you are able to do, and we'll have some doubt session for that. Okay. Okay then.